proving the validity of certain results involving natural numbers. Okay, mathematical induction is one of the method of proving the validity of certain results that involve what? Natural numbers. Okay, it is one of the method. So there is a principle to solve using mathematical induction. So that is principle of mathematical induction. Mathematical induction. So what is the principle of mathematical induction? So step 1 is the given statement is true. That is, I call the given statement as P of n, and P of n is true for n is equal to 1. This is the first step. First we have to call the given statement as P of n. So we have to prove that P of n is true for n is equal to 1. That is what? P of n is true. Okay, n is equal to, we have to take n is equal to 1. We have to show that the given statement is true for n is equal to 1. Okay, this is the first step. So the steps 2. So second step is assuming P of k is true for some k. So in the first step we prove that the given statement is true for n is equal to 1. Okay. In the second step we have to assume that the given statement is true for some k, that is P of k is true. Okay. The third step is prove that P of k plus 1 is true. So this implies by mathematical induction the given statement is true for all natural numbers. So this is the principle of mathematical induction. So we prove some mathematical statements. So using mathematical induction, they are asking that prove the statement using mathematical induction. To prove the given statement using mathematical induction, this is the step. In the first step, first we have to take the given statement as P of n. Okay. After that, we have to show that P of 1 is true. That is, we have to take n is equal to 1. In the first step, we have to show that the given statement is true for n is equal to 1. Okay. After that, we have to assume that P of k is true for some k. For some k, we have to assume that the given statement is true. After that, in the third step, we have to show that, or we have to prove that the given statement is true for k plus 1th term. Okay, we already here assume that P of k is true. Okay, we have to show that the given statement is also true for k plus 1. That is, we have to show that P of k plus 1 is also true. Okay, if all the steps are proved, hence by mathematical induction, the given statement is true for all natural numbers. So I will do one problem, then you clearly understand. This is the principle of mathematical induction. I will do one problem, then you clearly understand the principle of mathematical induction. How to prove the given statement using mathematical induction, you can clearly understand. Okay, shall we do the problem? So the first problem is prove by mathematical induction. Prove by mathematical induction that 1 plus 2 plus 3 plus etc. plus n equals n into n plus 1 divided by 2 for all n belongs to n. Capital letter n means set of all natural numbers. So this is the problem. So we have to show that 1 plus 2 plus 3 plus etc. plus n is equal to n into n plus 1 divided by 2 for all n belongs to n means set of all natural numbers. We have to prove this one using mathematical induction. Okay, in this chapter we all prove the given statement using this principle only. Understand? So how to prove using mathematical induction? So first step. What is step 1? For the first, let p of n is equal to 1 plus 2 plus 3 plus etc. plus n is equal to n into n plus 1 divided by 2. So the first step is we have to take the given statement as p of n. So real statement ಕೊಟ್ಟಿರ್ತಾರೆ ಅದನ್ನ ನಾವು p of n ಅಂತ ನೇಮಿಂಗ್ ಮಾಡ್ಕೋಬೇಕು. This is the first step. So after that, if n is equal to 1, so we have to show that step 1 is we have to show that p of 1 is true, right? So if n is equal to 1, so observe that p of n means 1 plus 2 plus 3 plus etc. plus n. So here we have n terms here. Okay, if n is equal to 1 in LHS, so what we have, it becomes 1, right? So p of n is it consists of n numbers. So n idre n numbers ide anta meaning. So n is equal to 1 anta tagolta idivi. So it becomes what? It has only one number, that is 1. Okay, so in the RHS, if in the LHS it has nth term, n number of terms, then RHS becomes what? N into n plus 1 divided by 2. But here we consider that n is equal to 1. So RHS becomes, put n is equal to 1. Okay, so n means 1 into n plus 1 means 1 plus 1 divided by 2. Right? That is equal to 1 into 1 plus 1 is what? 2 divided by 2. 2 gets cancelled. So the answer is 1. So therefore LHS is equal to RHS. That is p of 1 is true. Right? So we get LHS as 1. Also RHS is also equal to 1. LHS is equal to RHS. That is p of 1 is true. That is the given statement, if we take n as 1, the given statement is true. This is the first step, right? So what is the next step? Step 2. So assume that p of k is true. Assume that p of k is true. So p of n means 1 plus 2 plus 3 plus etc. plus n is equal to n into n plus 1 divided by 2. So p of k means what? That is 1 plus 2 plus 3 plus etc. plus k is equal to what? K into k plus 1 divided by 2. So here we have to assume. Naave assume ಮಾಡ್ಕೋತಾ ಇದೀವಿ. So 1 ಗೆ true ಆಗಿದೆ. So it is true for some k. So k ಗೆ true ಆಗುತ್ತೆ ಅಂತ ನಾವೇ assume ಮಾಡ್ಕೊಳ್ತಾ ಇದೀವಿ. So if it is true for k, then this becomes what? 1 plus 2 plus 3 plus etc. plus k is equal to k into k plus 1 divided by 2. So ಇದನ್ನ ನಾವೇ assume ಮಾಡ್ಕೊಳ್ತಾ ಇರೋದು. So 1 ಗೆ true ಆಗಿದೆ, k ಗೆ true ಆಗುತ್ತೆ ಅಂತ ನಾವೇ ತಗೊಳ್ತಾ ಇದೀವಿ. That's why I write this. Okay, this is the second step. So what is the third step? That is step 3. Show that or prove that p of k plus 1 is true. So here we have to show that p of k plus 1. So k tanka true anta tagondidೀವಿ. So the next term yadu k admere it becomes k plus 1. So we have to show that the given statement is true for k plus 1th term. Okay, that is, so k plus 1th term ಗೆ true ಆಗಿದೆ ಅಂದ್ರೆ ಏನು ಬರಬೇಕು ಸ್ಟೇಟ್ಮೆಂಟ್? 1 plus 2 plus 3 plus etc. plus k plus another term k plus 1. Right? So p of k tanka true ಆಗಿದೆ ಅಂತ ತಗೊಂಡಿದೀವಿ. taken. So we have to show that the next term, that is after k we have k plus 1th term, right? So we have to show that it is true for k plus 1th term. So that's why up to here k, the next term is k plus 1 is equal to, in this RHS also k becomes k plus 1. So k means k plus 1. Here we have k plus 1. K means k plus 1. K plus 1 becomes what? K andrene k plus 1 ಆಗ್ತಾ ಇದೆ, plus 1 it is equal to what? K plus 2. So k plus 1 into k plus 2 divided by 2. We have to show this one. So by principle of mathematical induction, the first step, first you have to take the given statement as p of n. So the first step is we have to show that p of 1 is true, that is n is equal to 1. So we have to show that or verify that LHS is equal to RHS if we take n as 1. So in the next step we have to assume that the given statement is true for some k, that is p of k is true. So after that we have to show that k plus 1th term, so k admele the next term is k plus 1th term. So we have to show that the next term igu idu true agutte anta torisbeku. So prove that p of k plus 1 is true. So p of k plus 1 true agutte andre ಏನು ಬರಬೇಕು statement. So k term andre ಇದು ಬರುತ್ತೆ, k plus 1 andre we have another one, right? So that is equal to, put in the place of k plus 1 ಅಂತ ತಗೋಬೇಕು. So k becomes k plus 1. So here we have k plus 1. K plus 1 becomes k plus 2 divided by 2. So now we have to show this one. So ಇದನ್ನ ನಾವು prove ಮಾಡಬೇಕು. Okay na? So how to prove this one? So observe that here we have 1 plus 2 plus 3 plus etc. plus k. So up to here we know the answer, right? So consider the LHS. What is the LHS? 1 plus 2 plus 3 plus etc. plus k plus k plus 1. I just consider the LHS. So we know that, so 1 plus 2 plus 3 up to k tanka ಏನು ನಮಗೆ ಗೊತ್ತಿದೆ, we already assumed that 1 plus 2 plus 3 plus k up to k is equal to what? K into k plus 1 divided by 2, right? We already assumed this one. So 1 plus 2 plus 3 plus up to k becomes what? K into k plus 1 divided by 2, right? So illinda up to k andre we know that k into k plus 1 divided by 2 plus, so the another one is k plus 1. Okay, simplify this one, that is take LCM. So 2 is the LCM. So k into k plus 1 plus 2 into k plus 1. Okay, cross multiply this one. Oh, it becomes k into k plus 1 into what? 2 into k 2k plus 2. Okay, divide by 2. That is equal to, so it becomes k into k square plus k plus 2k plus 2 divided by 2. That is equal to, so k square plus 2k plus k is equal to 3k plus 2 divided by 2. Okay, now you factorize this one, we get k plus 1 into k plus 2 divided by 2. Understand? This is the third step. So what is the third step? We have to show that p of k plus 1 is true. P of k plus 1 true agutte anta we have to show that. That is what? So this is up to k. So k plus 1 next term ತಗೊಳ್ತಾ ಇದೀವಿ, that is it becomes k plus 1. So put k ಗೆ k plus 1 ಕೊಟ್ಟಾಗ ಏನಾಗುತ್ತೆ? k plus 1 ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ? k plus 1 plus 1, that is k plus 2 divided by 2 ಆಗುತ್ತೆ. So we have to show this one. ಇದನ್ನ ನಾವು ತೋರಿಸಬೇಕು, ಪ್ರೂವ್ into k plus 2. Okay, so for this I replace k plus 1 into k plus 2 whole divided by we have 2. Okay, therefore p of k plus 1 is true. Okay, in the last line write down hence by mathematical induction. So can I write here? Okay, hence by mathematical induction, it is true for all natural numbers. It is true for all natural numbers. This is the method solving the given statement using mathematical induction. So mathematical induction prakara solve ಮಾಡಬೇಕಂದ್ರೆ this is the step. In the first step take the given statement as p of n ಅಂತ ತಗೋಬೇಕು. In the next step we have to show that p of 1 is true. So that is n is equal to 1 ಅಂತ ತಗೋಬೇಕು. So in the given statement nth term ಇದ್ರೆ n terms ಇದ್ರೆ 1 plus 2 plus 3 up to n terms ಇದ್ರೆ here we have p of n. So 1 ಬೇಕಂದ್ರೆ so 1 ನೇ term ಆಗುತ್ತೆ n is equal to 1. So LHS becomes 1. So in RHS also put n is equal to 1. Simplify this one we get 1. So LHS becomes is equal to RHS, that is p of 1 is true. In the second step we have to assume that is the given statement is true for some k, that is assume that p of k is true. That is what in the place of n put k. In the third step we have to show that the given statement is true for n is equal to k plus 1, the next term ಅದಕ್ಕೆ ಪ್ರೂವ್ ಮಾಡಬೇಕು. So prove that p of k plus 1 is true. So k plus 1 ಅಂದ್ರೆ k ಆದ್ಮೇಲೆ next term ಬರ್ತದೆ 1 plus 2 plus 3 plus etc plus k plus what k plus 1, that is equal to in the RHS also put k in the place of k plus 1 ನ ತಗೋಬೇಕು. So it becomes k plus 1 ಆಗುತ್ತೆ. ಇಲ್ಲಿ already we have k plus 1. So k ಗೆ k plus 1 ಕೊಟ್ರೆ k plus 1 plus 1 ಆಗುತ್ತೆ, that is k plus 2 divided by 2. So ಇದನ್ನ ನಾವು ಪ್ರೂವ್ ಮಾಡಬೇಕು. We have ಇದನ್ನ ಅಸ್ಯೂಮ್ ಮಾಡಿದೀವಿ, ಇದನ್ನ ಪ್ರೂವ್ ಮಾಡಬೇಕು. Okay, so for that consider the LHS. Okay, we know that 1 plus 2 plus 3 plus etc plus k is equal to ನಾವೇ ಅಸ್ಯೂಮ್ ಮಾಡ್ಕೊಂಡಿದೀವಲ್ಲ ಏನು k into k plus 1 divided by 2 ಅಂತ ತಗೊಂಡಿದೀವಿ. So replace ಮಾಡಿ. So remaining term is k plus 1. So LCM ತಗೊಂಡು simplify ಮಾಡಿ you will get k plus 1 into k plus 2 divided by 2. Okay, therefore what p of k plus 1 is also true. Hence by mathematical induction the given statement, that is the given statement is true for all natural numbers. ಈ ಮೂರು step true ಬಂದ್ರೆ the given statement is true for all natural numbers. Understand? I will do some more problems using mathematical induction in my next session. Okay.